Recorded.
Start the recording. Yeah.
Yep.
Okay.
Okay, so we're here February 22nd, 1:36 p.m. To do a structural advisor committee for 1900 through 1990 Diamond Street. Pursuant to San Francisco Building Code sections 105.6 and 106.4.1.4, a structural advisor committee was formed to provide independent expert review and to make recommendations to the Director of Building Inspections on the proposed new building construction permit applications on sites which are proposed to be excavated, graded, and 5 new buildings erected near 1900 Diamond Street under permit numbers 202205 124153, which is 1900 Diamond Street, which is a 4-story single-family dwelling. Permit application number 202205 124157, which is 1902 Diamond Street, also a 4-story single-family dwelling. PA number 202205 124111, 1950 Diamond Street, which is a 4-story 20-unit residential building. Permit application 202205 124175, 1980 Diamond Street, which is a 4-story single-family dwelling. Permit application 202205 124119 on 1990 Diamond Street, 4-story single-family dwelling. Undergoing such SAC heightened design review as being within the zone subject to Slope and Seismic Hazard Zone Protection Act for San Francisco Building Code section 106.414. The SAC members that were selected was Craig Shields, geotech engineer, John Wallace, certified engineering geologist, Benjamin Lai, structural engineer, and Harvey Hacker, architect. The background, under the conditions of the Slope Protection Act, SFBC 106A.414, the proposed project is subject to mandatory submittals and heightened reviews of reports by a structural advisor committee as defined by SFBC 105A.6. The proposed permit applications are proposing site excavation and grading and construction of earth retaining structures and new residential buildings along a very steep slope along the hillside and are subject to the requirement of the review of structural advisor committee. The structural advisor committee will convene to review and provide expert professional opinions concerning items and stipulated in SFBC section 105A.63 and 106A.4.1.4. The subject permit application is under the jurisdiction of the 2019 edition of the San Francisco Building Code, being the version prevailing at the time. We'll read the note to public comment. The Structural Advisor Committee will take public comment on all items appearing on the agenda at the time the item is considered by the SAC. For general public comment, item number 3, the public may address the SAC on any issues that are in general subject matter under the jurisdiction of the SAC, other than the calendar items. Each member of the public has up to 2 minutes to comment on an item. As a SAC review involves complex technical, geotechnical and geological and structural issues and considerations, to facilitate efficient progress in the review, agenda items 4 and 7 may take place in interlaced fashion or for various areas of review concerns as appropriate as determined by the call of the chairperson. Okay, so let's do a roll call. So I'll do mine. I'm Philip Chan, plan reviewer for DBI from Review Services. Willie, would you like to know?
Rockridge geotechnical reviewer.
Benjamin Lai, historian reviewer.
Let's do the SAC member roll call first. So, for everyone.
Like somebody there.
Philip, you called out the SAC member.
Yeah. So Craig Shields, geotechnical engineer, are you here?
Yeah, Craig Shields.
Okay. John Wallace, certified engineering geologist.
John, you unmute yourself.
What are you apologizing for? Crumbs? Oh, come on. We're having trouble. Ooh.
Let's see. John, you calling in?
Might be having some difficulty. I saw him on video.
He was here earlier.
Yeah. Okay. Let's give him a minute. Let's do Harvey Hacker Architect.
I'm here.
Nothing that's supposedly on video.
We'll wait for John. Let's do the applicant design team and sponsors first, and then hopefully John will be able to get back onto this call.
I'll go first. Mark Babson from Emerald Fund, project sponsor. And then Shane Harris is also with Emerald Fund. Langan, you want to go next?
Sure. Scott Walker with Langan, the geotechnical engineers on the project. I also have Richard Rogers on the geotechnical side. And of course, Josh Goodman, our engineering geologist on the project. Makes up the Langan team.
And how about IMEG? You're muted.
You're unmuted, but we couldn't hear you.
Hi, can you hear me?
Yeah.
I'm Eric Agnes, and I'm here with Joe Goldman. We're the structural engineers of record for this project.
Would you like a little ginger ale?
Erwin, you want to go next?
That's not me with the ginger ale. I'm Erwin O'Toole, shoring engineer.
BKF.
I'm
Christine Gursky with BKF Engineers. I'm the civil engineer on the project.
Landscape.
Hello, I'm Brendan Cox, landscape architect with Molly Wood on my team here as well.
And SCB.
Hi, this is Yihui Gan with SCB. We're architect on the project.
I think that's everyone on our team that's here.
Yeah. So we're waiting for
Ladies
John
and gentlemen, I just want to remind the applicant team, you would be taking the reading minutes, and the recording will be available to you for reference in case you want to do it, to put in the meeting minutes for the SAC.
Hey, Iwe, how do you feel about taking minutes as the master architect?
Yeah, I can do that.
All right, thank you.
No.
We're waiting for John to get back online.
Yes.
Does someone can someone text him or call him or something? Does someone know his number?
Started. Yeah,
Nope, now we see him.
I'm John.
John.
Hi, John.
Hey, I got spit out for some reason. I just had to reconnect.
Well, we just finished the roll call, so
I'm here.
yeah, I think you, uh, I think your counterpart is the geologist and is in language. That's Josh Goodman, right?
Yeah.
Okay. So,
Okay, so let's continue. So we just got done with agenda number 1, roll call. So I'll leave it to the SAC to do number 2, select a chairperson to conduct the SAC review meeting, and that chairperson will continue down the agenda.
any motions from these SAC members or electing the chair?
Well, John Wallace is chair, isn't it?
Thanks, Ben.
Any second?
I second.
Okay. So let's take a vote. Whoever is opposed, say opposed on the SAC members. Okay. In favor, say aye.
Aye.
Okay. And John, you have no objection?
No, as long as I don't get spit out of the program again.
Congratulations.
Okay, so the floor is on you. We have the agendas from, I think, agenda item number 2 is done, and number 3 is public comments on item other than the calendar items. So let's see if we got any public on this thing here, any call. So let me see. Better get to the instructions. Okay. So the dial-in folks can, let's see, dial-in folks from the publics can press asterisk, then press 3 to raise a voice on this thing here. I did not see any hands raised here. Okay. Okay, so I think this, I give it half a minute to see if anybody's got that public comment. Okay, I don't see any public comments on this item, so we're gonna close that item number 3, agenda item number 3, and then we're gonna move on to item number 4 to 7, which happens to be the discussions on this thing here. So I think for the first round of this thing here, Philip, you want to spell out the agenda item 4 to 7, just to get an idea what we are discussing about.
Hey, Willie, one thing
Yeah.
I wanted to reiterate right up front is the meeting minutes should be documented by the project architect and their
Yes,
team.
we had that. We had that while you were offline. So
Okay.
yeah.
Okay.
Okay. So they will be given the recording. That we have the recordings in place. So that is going to recording to help them remind them. But the thing is, they're supposed to, pick up the items as along the way.
Okay.
Yeah, I'm taking the notes.
Okay. So I'm gonna read through the agenda 4 through 7, I believe. All right. So number 4, applicant team presents proposed project with documents and plans. Number 5, scope of SAC review and discussion for SFPC sections 105A.6.3 and 106A.4.1.4. The SAC will perform the design review to provide for the Director of Building Inspection with a written report concerning the following review considerations as applicable: the safety and integrity of the proposed design construction, the effect that the grading construction activity related to the project will have on the safety and slope stability of the area during the construction sequence and after the construction of at subsequent development stages, and the interim measures to mitigate any potential sliding and erosion of the site. The validity of the appropriateness of the geotechnical structural design concepts and criteria, adequacy of the geotechnical and geological investigation and study, and the appropriateness of the recommended design parameters, the evaluation of the grading design in preparation of the planned future building structural development to determine the appropriateness of the capability to perform the satisfactory without failure, any perpetual limitation of the site to be imposed regarding the level of future development, such as the future excavations and or vertical and horizontal additions of the original plan. Constructability of the proposed structural details and construction sequencing and methods, the sufficiency of the proposed inspection, testing, monitoring to be provided prior to, during, and after construction. The items to be reviewed will include, but not being limited to, the geotechnical, geological investigation and study, designs, details, drainage, erosions, during and after construction, construction, erection methods, appropriateness of and adequacy of the proposed shoring design, quality control and special inspections specified, site monitoring plan during and after improvement and installation are constructed, the necessity of the follow-up review by the SAC for the additional site finding by the geotechnical engineer and certified geologists of records during the grading, excavation, and construction are assumed and recommended geotechnical and geological design parameters. The review shall include the evaluation of the stability of the project site with regard to the proposed subsequent development and the effect of its development and the stability of the adjacent areas. Review will consider factors including but not limited to design criteria and performance objectives, soil and site conditions, geological factors, historical site stability, the anticipated foundation system designs, soil and site improvement systems design, shoring, earth and retaining system design, structural systems design, on and off-site drainage impacts, and other proposed improvement designs for compliance with the design criteria, performance, and objectives. Number 6 would be public comments. Number 7 will be SAC panel discussion. Number 8, motion and recommendations to the building director of building inspection for incorporation into the project design, if any. And 9 would be adjournment. Okay, and I'll turn it back to the chairperson, John Waltz.
Okay. Item number 5, we'd like to throw it into the project team's hands and maybe get a quick overview from the architect on the general scope of the project. And then the architect can hand it over to probably go geology, geotech, structural, and shoring in that order. And let your team weigh in on any items in their area of expertise that would help summarize the project for everybody. And along the way, after each respective area of expertise is addressed, there will be action items called out, and those are critical that those get documented in the minutes. And so we'll try and be very clear on the action items, things that will require future addressing by the team. So we'll pay particular attention to those and raise those kind of during each area of expertise commentary. And I guess now would be the best time. I'll go ahead and read into the record the documents that have been provided by the project team for the Structural Advisory Committee review. And let me start. So in my file, I've got a geologic hazard and geotechnical evaluation report prepared by Langen Engineering and Environmental Services, dated July 31st, 2020. We have a supplemental geotechnical recommendations letter regarding micropiles prepared by Langen, dated September 15th, 2022. We have a structural plan sheet or plan set with 45 sheets prepared by IMEG Consulting Structural Engineers. The latest revision that I have is dated September 15th, 2022. We have a civil plan set with 16 sheets prepared by BKF Engineers, dated July 21st, 2022. We have architectural plans, 103 sheets prepared by Solomon, Coldwell, and Blaine's. Architecture and design, latest revision, September 15th, 2022. We have landscape plans, 48 sheets prepared by Groundworks Office, Inc., dated September 2nd, 2022. And we have shoring plans, 8 sheets prepared by Irwin O'Toole, dated July 8th, 2022. And that's the summary of documents that I have. If there are revision dates that are later than those, let me know and let us all know. But that's what I have.
Great. So I think that is everything. So this is Mark Babson, project sponsor. We actually have a presentation that's kind of all ready. It's mostly in the order you said. I think it goes. I was going to cover the intro as opposed to the architect, just sort of a brief lay of the land. Then we're going to go geological, geotech, shoring, then structural. Is that okay if we do it in that order?
Sure, if you've got it in that order,
Okay.
Go for it.
And then we'll just change over. It's the same deck, but we'll just change over presenters. I think everyone's got access to, everyone on our team, I think everyone has access to the deck. So you can share it when you're up. That way you can sort of zoom in on what you want to zoom in on. And then so I'll just start share. Okay, is that, everyone see that?
Yeah.
Yeah, okay, great. So we already did the introductions, but yet again, these are just the team members: Langen, Geotech and Geological, Irwin and Granite for shoring design, IMEG structural, BKF civil, Groundworks landscape, SED architecture. So civil and landscape and architecture don't have a presentation part, but they're available to answer any questions and involve in dialogue. So I think we all know the site now. It's a 3/4 acre site. Slopes, pretty decent slopes, both directions, east, west, and north, south, at the corner of Diamond Heights Boulevard and Diamond Street. And it's never been developed in its history. Currently has a bunch of trees, approximately 30 trees, mostly Monterey cypress. Through extensive community engagement, we ended up preserving 10 of the trees. And so it's kind of a non-traditional plan. You can see that that these duplexes are pushed off of Diamond Street, and it makes for kind of a non-traditional development. But so a bunch of different building types, as you'll see in a second. So there's, I think we call it 5 buildings, maybe 6, that range from all wood all the way over to the left, single-family homes, to an all-concrete building to the right of that, and then a couple of 4 stories of wood over 1 of concrete. And in the back, the 5 stories is 2 stories of wood over 3 of concrete. That's their garage and lobby with townhouses above. Structure, we'll get into this, but this is kind of just again, a lay of the land. These are just pictures. You can kind of have visuals of what it looks like before we get into the technical stuff. So this is on the north side of this site. This is Diamond at 29th. Those are the cypress that exist and will remain. Behind that, over to the right, you see the single-family homes, and then duplexes 7, 8, and 9. This is kind of midway on Diamond Street where Beacon hits, and you get to see a few things here. Starting on the left, it's duplexes 2 through 6. Above that is the 2 townhomes that are top of the garage, where you can actually see one of them there. And then on the right, where after the green break is duplex 7, 8, and 9. This is still on Diamond Street. This is duplexes 1, 2, 3. You see a little bit of 4 and 5 off to the right, and kind of looming above that is the top of the garage building, the top duplex there. And we've got a public stairway on the left there, and you can even see people above the 4th floor. That's a public deck. And then when you're up on Diamond Heights Boulevard, it's much smaller. Starting from the left or the north, you've got, again, that garage building with a garage structure and then 2 units above. You also have your lobby there. Then a break where the stairwell is, and then 2 single-family homes. And then it's someone's yard on the right. So with that, I'm going to hand it off. I don't know if John or Scott wants to go first, but and I'll stop my share so you guys can control your own tech.
Can everybody see my screen?
Yeah.
Super. Give me just a second to get set up here. All right. Well, greetings. I am Josh Goodman. Just as a reminder, I am a senior project geologist with Langen. I'm a certified engineering geologist as well as a professional geologist in California. And just to give you kind of the overview or the roadmap of where I'll go with my part of this topic, I'm going to start by giving some contextual information. So share what we were able to glean from the surface, from public literature. Then we'll look at the subsurface. I'll summarize the subsurface information. And then I will loop back and discuss some of the slope stability settings. So what we're looking at here, this is a published regional map by Schlocker. And our site here is in this sea of what he's mapped as ravine deposits, the superficial units. And then you can see that it's surrounded by bedrock of the Franciscan complex, including sandstone, Churton shale, and then I'll also point out there's some greenstone mapped nearby, and I'll come back to that when we talk about some of the subsurface data that we collected. And then just the last thing I'll point out, here's the strike and dip data. While it does vary around the area, both to the left of the site and to the right, it indicates that the bedding or the layering within the bedrock is to the west, which is into the slope. Just to touch on what Mark says, this is a contour map. These are, the index contours are 5 feet. North is to the right, so this slopes generally to the east. The slope is about less than 10 feet to the south, over 70 feet to the north, and it slopes between about 2 to 1 to 1 1.25 to 1. This is saying a very similar thing. This is from the City of San Francisco slope map. And you can see that the site encompasses areas that are defined as being 25% or greater. And I'll just point this out. I'll come back to these later on. There are these 3 sites that we'll bring up when we're discussing the slope stability issues. Here's our site plan, and I'll just point out our subsurface exploration program consisted of looking at 3 main types of data, or I guess 2. One comes from test pits, which are shown by the black and white checkers. We've got what we're calling trenches down here, and these were excavations that were about 3 to 4 feet deep. These were made for some of the landscaping that was done on. We went in and we logged those as well. And then we also, through our subcontractor, collected 2 seismic refraction profiles. Those are shown as A and B here. And what I'd like to do now is just at a very high level share some of the findings from the subsurface information. We'll look at this cross-section profile 2 and profile 3, which go through the highest slopes on the site. And then we'll come back and look at the seismic refraction data. So really quick, this is just an example of our test pit log here. This is 2 feet for scale. And in contrast to what I was showing you with that Schlocker map, the regional map, with one exception, our test pit that we found at the south end, everything else was essentially all in bedrock with a thin veneer of topsoil. Our southernmost test pit, we did find, I think it was about 18 inches to 2 feet of what looked like a surficial deposit that could be consistent with colluvium or those ravine deposits by Schlocker. But again, we are mostly in bedrock, and that the rock that we were able to identify included chert, shale, and sandstone. And then this is a key point to make with respect to slope stability. Both the bedding as well as some of the joints or the fractures consistently dips into the slope. And just to give you kind of an intuitive understanding of what that looks like, here's just a representative photo of what we were finding in our test pits. So you can see this blocky material. This is the bedrock. This is the spoils pile here, and hopefully this is obvious, but you can see these lines or these stripes crossing the excavation. That's the stratigraphic layering, and that's inclined into the slope. And here's the first of the 2 cross sections that we wanted to show you. This is the existing profile here. In case you can't read, this is 10 feet, each of these heavy marks. This is a 1-to-1 horizontal to vertical scale, so no exaggeration. North is to the right. These are the 2 test pits that intersected this cross-section line. And what we're showing here are this lollipop-looking thing. This shows the measured orientation of the stratigraphic layering, so the apparent dip, so that's resolved into the plane of the section. And then the square-looking lollipop, that shows the apparent dip of joints. And what we've done, this is the proposed excavation outline in blue. And what we've done with these thin lines is just take that structural information and show conceptually what we think, if it's consistent into the hill slope away from our test pits, what effect that might, or what that geometry might look like during the cuts. And like I said before, we do think that that consistently across the site that that is inclined into the hill slope. Just the same thing here, so won't go into the level of detail. Only differences of the geometry of the cut will be a little bit different. And then here in red, this is a retaining wall along the western site boundary. But again, the take-home message is, based on our subsurface investigation, we do feel like we've got pretty consistent conditions across the site, and that those conditions are defined predominantly by bedrock of the Franciscan. Here to look at, share with you the findings from the seismic refraction data. Again, also, here's the scale here, the index down here. So the purple colors indicate faster velocities, perhaps denser materials, and then the warmer colors, relatively lower velocities. And this yellow line shows the 7,000 foot per second contour. And the reason that we're emphasizing that is that's generally corresponds to the upper limit of what can be ripped with a D8 dozer, so kind of a common earth moving equipment. And really the take home message here is that one, the material, the velocity structure does, or the velocity of the material increases with depth, that, and we're interpreting that as being evidence of probably a decrease in weathering, possibly a tightening of the fractures that we were able to observe in our test pits, and just an overall increase in the competency of the bedrock with depth. And that, of course, is important because as we saw in our geologic cross sections, these excavations will be, kind of founded in this kind of more competent material. So just to kind of wrap this up now with the slope stability, this is a snapshot from the California Geological Survey from their seismic hazard map of the San Francisco 7.5-minute quadrangle. And I know it's a little bit faint, but in red here, this is our site outline. And we've got a polygon, little pieces of these areas that they're mapped as potentially prone to earthquake-induced landslides. And I think specifically with our site, probably the reason that these areas were flagged has to do with the last part of this clause, that has to do with the local topographic characteristics. Specifically, we've got steep slopes. And then regarding the geological and or geological conditions, it is possible that based on the Schlocker map where there were these surficial deposits, that while we didn't encounter them or we only encountered them in a very limited spot, it's likely that if those things were there, that they may have been removed during possibly grading of Diamond Street or Diamond Heights Road. But in general, we don't have those conditions here. And again, shallow bedrock. And then I wanted to come back to just point this out. North of our site, there was a series, there were some slope failures that impacted some of the nearby properties. This was associated with the Vista Del Monte apartment buildings, and reading and reviewing the reports, our conclusion was that yes, these landslides have occurred near the site, but if you look at the conditions that they concluded led to those landslides, very different from the bedrock that we had at our site. Specifically, they documented, between about 10 to 17 feet of fill soils over a claystone bedrock. And the conclusion was that the failures were happening along that interface of the rock and soil, which we don't have. There was also a natural spring that was present. No groundwater was encountered at our site during our investigations. And then there were also a series of other anthropogenic factors that they thought might have also contributed to the landslide. And that includes, the presence of a retaining wall and other water conveyance features. So that is all I have, and I will now pass the baton on to my colleague, Scott Walker. Oh, I'm sorry, one last thing. The only evidence of slope instability that we documented at this site was very superficial raveling or, creeping of loose material under the effect of gravity, very small, predominantly soil with gravel size materials. So now I will hand it over to Scott. Scott, let me know if you want me to drive or if you want to, I can stop sharing.
Okay, why don't you go ahead and stop sharing and I'll give it a shot.
Thank you.
All right. Let's see if this works here. Can you guys see my screen?
Yes.
Perfect, thank you. Thanks, Josh. Again, I'm Scott Walker with Langen. I'm a geotechnical engineer in the state of California. And we've done this, worked on this project in conjunction with Richard Rogers, who has a lot more experience than I do, which is a great resource to have. Really quickly, we'll jump from the raveling story of the surface kind of potential instabilities into a 3D picture. We've seen what these buildings look like up in the air, and we've seen cross sections. But this is a view from the west, I suppose, or sorry, from the east. And it's kind of looking into what the building will be founded in. So we talked about there being bedrock on site, and there being potentially a more competent bedrock as you go down. This is a 3D view that shows the potential, or actually the planned various shoring systems and the foundation levels that are being proposed across the site. So the idea here is that all of the buildings will be founded in bedrock, essentially on shallow foundations, supported in bedrock, and all of the planned cuts that are upslope, that are could potentially have a hazard associated with either the nearby improvements on Diamond Heights or the nearby structures, will be actively supported with shoring systems. Whether that's a permanent retaining wall, in some cases, like it's shown in red here, that's the cantilever wall that was shown on Josh's figure, or some of these blue and orange walls, which are will be covered by Irwin. It's a combination of temporary shoring for the construction condition, and then the buildings themselves end up supporting the load that's potentially on those walls to protect our upslope improvements. As Josh discussed, we did not find any groundwater on site. However, our experience is that groundwater can travel through fractures in the rock, especially as you get to more and more competent rock. Rainwater gets trapped in those fractures. So the overall project has been designed to have all of the walls back drained to make sure we don't get any accumulation of groundwater behind these systems. We don't load up the walls as well. So back drained, and then the bottoms of the slabs or the foundations of each of these units is going to have an underslab drain system. So all that water is collected, and then because of the site slopes we have, they can drain by gravity and exit the site down here into an appropriate system. We have a couple, these are the same cross sections essentially, or similar cross sections that Josh showed. Now we've got the proposed layering of the buildings. I'll let IMEG talk more about these, but as you can see, the original ground surface is there highlighted kind of behind. The intent is that the building steps into the below the ground surface in every location. So we're not perched up above the existing ground surface, and all of those surficial materials that were present potentially across the site ultimately are removed. There's no planned cuts that are unsupported on the upslope side of the site. So we're not steepening any slopes or anything like that. Everything's actively shored. Let's see. These are some of the design parameters that have been presented in our reports. What we've done here is we've taken the given wall pressures, both for the shoring conditions as well as the permanent structures, and we have determined those what the loads on those systems will be based on the slope of the ground surface up above the wall. Clearly, the steeper the slope, the more load that needs to be retained to actively mitigate any potential for movement on the upslope side. And those with a keen eye can see that we've accounted for the fact that much of this rock may be really fractured. So essentially, we're using soil parameters with a pretty high friction angle, but soil parameters as the guiding principle for the various shoring and wall pressures, because the fracturing we expect to be variable throughout the system. So we're not counting on the rock all being intact and holding itself up for any of the values. Here is the portion of the shoring that will be tied back or braced, temporary shoring and lagging. Again, we've got here we're using a trapezoidal system for the apparent earth pressure diagram. Again, we've got a slope where we have sloping ground conditions. We have variable values in the table. The document that this figure is from was actually a supplemental document as well. It was not listed, John, in your list. I'm not sure if you guys have it. If you don't, we certainly can. That can be a comment that we can close by providing it. We believe it was included in the package that was sent.
Yeah, I haven't seen that.
This particular one. Okay. Thank you for that clarification.
Yeah, I think it's in the slopes or shoring letter. We had two supplemental letters, right? One was micropiles and one was shoring.
That's correct. Those are the two.
Okay.
And here we're coming back to this 3D view just to kind of get an overall approach to the various shoring Erwin O'Toole is going to pick it up from here and talk in detail about the various shoring activities. But again, we can see, you know, we do have some of the improvements. So the buildings that are nearby, we have the one-story garages, 2 to 3 story structures here that are kind of embedded into the hill slope a little bit, and then a 4-story structure down here on these sides. All 3 of these are supported by the various shoring systems as planned. I think, Erwin, I'm going to pass it on to you.
Good afternoon. My name is Erwin O'Toole. I'm the shoring engineer for this project. Can everybody hear me?
Yep.
Yes.
Okay, I'll proceed. So I noted, John, in your opening notes, you said that you had 8 pages of shoring drawings. There is a 16-page document dated 12/2 that's been reviewed by our team as part of the package. So that's, I hope that that's the one that's being reviewed. It's dated 12/2. But anyway,
Erwin, can you
on the
speak
screen
up
here,
a little?
Oh, sure.
Yeah,
Yeah. Can you hear me better now?
You're pretty muffled. I don't know what's.
Okay, 1 second, please. Okay, how's this? Thank you. So in front of us here on the screen, we have the 4 types of shoring that we've planned. In orange, it's soldier beams and lagging. With the blue, which is a snail-designed shotcrete soil nail wall. The red is permanent cantilevered beams. And then the green is a combination where we have a beam holding a concrete-faced wall. Again, these cuts have been mentioned. Here we have the back cantilever wall leading into the back units with the blue in front of it down to the soil nail wall. Similar cuts here have already been referenced by other members of the team. This is the type of cut that we expect, and here's a similar SAC-approved project drilling in this type of formation. These type of machines are actually pretty small footprint given the size of and the type of soldier beams that we have. Luckily for our project, there is access on both the top and the bottom of the slope, which makes it a little bit less of a challenge compared to some other projects in San Francisco that have been reviewed by this panel. The next image is simply just showing for the general public, showing some soldier beam lagging and tiebacks. And here, the following image, we have what is in blue on my drawing is a shotcrete wall with soil nails, and more importantly here we see this drainage panel here. So this is the type of conditions we expect on the site with the nice clean lines and a sequenced stepped formation with an adequate bench size to install these soil nails or tieback. Or here, next image is simply the shotcrete wall being installed with the last lift at 6 feet there. Another similar type of condition up here, we've got some of the drainage layers in place, and we have a pneumatic hammer, tieback rig, and mesh over here. Again, up at the top of the cantilever area, this is the type of look, the exposed lagging with oversized beams. And in green, we have the area where we have soldier beams and then a shotcrete facing. Next, we're looking at some of the traditional drainage techniques for both the temporary condition behind the walls. And this mirified type product actually gets put in place in two locations. One, behind the shotcrete, lagging, or the shotcrete soil nail wall. And actually, as part of the waterproofing system, it also gets placed in front of it to ensure adequate drainage. And that is actually, location is here, and where there's shotcrete, it's here and here. So one of the items that many of the items that we try and discuss and that I take on board is the temporary and permanent shoring design, which we've used the geotechnical parameters that have been reviewed by the team, and the construction sequencing, which I think I should speak to a little bit here because I'm not sure how well this will present, but it's a 6-page document that's within the 16-page shoring plan. And what it tries to do is show the team each stage of how we build a project from the top. So a better way to actually present this is to go back to this image right here, and just talk through it. So it's presented in the construction document, but an overview would be we start off at the top of diamond, and we install the shoring in orange, and that's why I've chosen soldier beam and lagging in this location here. That allows access from the street to install these improvements. And then we build an access road from the left, which is the south, all the way over to the right. And that allows us then to travel in the top location here and install these soldier beams here, and eventually traverse our way across the site to the red area, which is documented in these sequencing plans, to allow us to install this cantilever, while continuously removing dirt off the site and managing any drainage as necessary. With that flat bench built, we can then proceed to top off some of this blue wall with short stacked soldier beams to get the grade to the correct elevation. And that allows us then to start the shotcrete and tiebacks in lifts. And that sequence of operations safely then allows us to exit to the east or bottom of the page. And in my 16-page document, I think I've presented clearly each step of the operation. And I'm happy to answer any questions as to the logic of how that's achieved. And I hope that you can understand it clearly. So with that, if you have any questions, please feel free to ask. Otherwise, I'll hand it over to structural.
So this is Craig. I think the 8 pages that John referred to was in that large.
Yeah.
Lines. We didn't get a separate. And you, Erwin, you said it was dated in December. Was that the date for your more recent one, or your 16-page?
That's correct. Yep.
Okay, so we don't have that. I don't believe.
I don't. Yeah. And I tried to access the portal for the documents several times and wasn't allowed to re-access it. So that's why I was wondering if there were other documents out there that had been updated since the ones we received initially.
Yeah, I'm wondering if this is gonna lead. Probably a lot of your questions and comments are going to be on the. It was an earlier version of the. That was a not complete set that it sounds like you reviewed. Is that true for the other groups or just for shoring?
Yeah, and I think Craig and Ben probably spend a lot more time on the shoring than I do, but I certainly had a lot of questions because just the couple of things that Erwin presented were things that I had questions on for sure on back drainage because none of that was illustrated on the first.
Yeah. Trying to make the most of this time with all the notice. Maybe everyone you could stop the share so we can see each other for a second. Erwin, are you able to walk everyone through your plans?
Yes.
Does that make sense, or do we just stop this meeting and reschedule it for a month from now? It's
Okay, thanks for calling, Wilson.
I think walking through the plans would be good for now. What do you think, John? I mean,
yeah, maybe
understood.
maybe finish the presentation, and then when we go through each respective area of expertise more closely, we can dive into the nuts and bolts of and start with our questions on the shoring, and Erwin can walk us through it that time.
okay. Yeah, I think I think that what the process was supposed to happen was, we gave you like a progress set to do the bidding, and then there was supposed to be, the review based on the final set. But sounds like something was lost in transition there. So, so rest assured the drawings were completed. But yeah, I think that sounds like a good approach, John. And I think we just have IMAG left. And did you have anything else, Erwin, from your presentation?
No, thank you.
Okay.
Yeah, so this is Joe Goulden with IMEG. We're the structural engineer record. Similarly, I think our set also has a December date on it, but we'll go ahead and walk through some structural concepts here. So thus far, we've heard conditions. We've heard a lot about the shoring. We're going to talk more about the permanent structure that'll be there. We'll touch briefly on the main structural systems, but the bulk of our discussion will be the bulk of our discussion will be on the the retaining system, because most of the structural systems are pretty standard. They're light frame construction. We have concrete. That's all pretty typical. To hold back the hill site, we have a buttress wall system with tie downs that help resist some sliding. So we have Eric Agnes here who's going to go ahead and walk us through some diagrams that we have and some in the structural systems.
Hi there. Thanks for the introduction, Joe. Can you guys see my screen?
Yes.
Yes.
So I'm just going to give a pretty brief description first of each of the buildings. And I'll dive deeper into the retaining wall structures and the foundations and how we've designed them to resist sliding loads. Just real briefly, this is our site. We have on the left S1, S2. This is just 4 levels of wood frame. To the right of that, we have building 1A, which has a garage structure that has 2 levels of concrete, and then units T1 and T2, which is 2 levels of wood framing above that. Below that structure, there is units D1 through D6. Unit D1 is 4 levels of raised concrete floor. Level 2 through, or units D2 through D6 are all wood frame structures. To the right of that, we have building 1B. 1B has 1 level of raised concrete floor with 4 levels of wood structure above that. And in 1 and 2 follow the same with 1 level of concrete and 4 levels of wood above that. Now I'm going to go into a deeper dive of each of these buildings. I'll start off with the left-hand side and move to the right. I also have a key plan at the bottom if you get lost. So starting off here with S1 and S2, we have a cantilevered retaining wall structure for this building. It's very common within the residential industry, especially where you have wood frame structures that aren't able to support your retaining wall. You have to typically design it as a cantilevered retaining wall. So this means the foundation alone is resisting that overturning force from the retaining wall itself. We can see here that in section 1, we'll start off with just our loading that we have for it. We got our typical triangle distributed retaining earth load. At this location, we also do have a traffic surcharge because we have the street that is close enough to impose that load. And then we also have our seismic loads as well. So all 3 of these interact to sliding force. Now, how that force is resisted is two ways for this building. We have our friction force, which is the interaction in between the bottom face of the footing and the soil itself. That friction can resist the movement. And then you also have the passive pressure, which is the vertical face of the footing being pushed against the soil itself. For these buildings, we have relatively small retaining loads in comparison to some of the other buildings. And the passive pressure alone was adequate to resist all sliding forces. Again, this includes both the retaining earth load, traffic surcharge, and the seismic load. The right of this, we have 2 sections. This is the wing wall. Again, here it's just 1 level of retained earth, and we're utilizing the passive pressure to resist that. Loads are a lot smaller because it's just 1 level of retained earth. And we also have some site retaining walls adjacent to that. We took those into account by just having a traffic surcharge, just to account for any sort of surcharge that would be implemented onto those. Moving on, we're now looking at building 1A. If we kind of focus our attention on the plan view first, we can give some just brief descriptions. We have the garage structure, which again has that concrete floor, which allows us to utilize that floor to make a restrained retaining wall, which means the concrete diaphragm is going to be supporting the top of the wall. This makes the retaining wall span vertically in between the green foundation here and the blue raised concrete floor. On the back side of units D1 through D6, we have a back retaining wall. This spans horizontally to each buttress wall, which is separating each unit itself. The buttress walls are shown here in blue. And then on the sides of unit D1 and D6, we have a wing wall, which is a buttress wall and also serves as a retaining wall because there is soil on the sides of the building as well. And one thing to note, we do have a site retaining wall that is connecting units D7 to D6. That'll play a part on the next slide. But for now, let's look at section 1, just cut right here through both the garage and D1. So if we focus our attention on the garage loading real quick, again, we have our typical retaining wall that's restrained. And we are resisting the lateral earth loads via friction within the mat footing for the garage. Because we're able to say we're resisting it with friction, we're not seeing any loads imposed onto units D1 through D3. Also, one other point that's to note here is the foundation is connected to the back wall, the back retaining wall of D units 1 through D3, which doesn't impose any surcharge load that would be acting upon the back retaining wall for those units. So moving forward to the units D1 through D6, this is our typical buttress wall system that we have here. It's pretty common where you have large retaining loads that you can't utilize a diaphragm to resist it. The buttress walls act as a point of resistance, so the back retaining wall would span horizontally to these, and then that load would get distributed to the footing below. That does create a TC couple, a tension and compression couple. And if we look at the left-hand side, I have a plan view example of what our foundation is. It's a kind of dog bone shaped structure. The toe of the buttress wall has a compression load that gets distributed to the soil via the spread footing. Is limited by the allowable bearing pressure. And then the vertical tension load is resisted by the gravity design, of course, and then we have vertical tie downs as well, where the gravity load alone is not adequate enough. We're relying on these tie downs to resist any movement vertically. As far as sliding is concerned, again, we have our building seismic load and our retained load as well. Those are resisted by, again, the same passive pressure and friction force that we talked about before with S1 and S2. We have another way to resist sliding as well for these buildings and the rest of the buildings moving on. It is a incline tie down. This is a tie down that's at an angle, reduces sliding. Pretty common. The next slide is our wing walls. The left one is unit D1. As I said before, unit D1 is all concrete floors. So we have a diaphragm there, which allows the retaining wall to span vertically. That diaphragm then distributes that load into the buttress walls and the back retaining wall. As far as sliding is concerned, we utilize the passive pressure to resist any sliding as the earth is pushed against the side of the building. For unit D6, we have wood frame structure, so we don't have that stiff diaphragm. So our retaining wall is spanning horizontally to that site retaining wall that I mentioned earlier, and then the back retaining wall. And then again, we're utilizing the passive pressure to resist any sliding forces here. One thing to note that is of significance, we have a permanent shoring wall at this location. And there's not very many locations where we do have this condition, but I thought it'd be good to bring it up here to account for that load that would be imposed onto our back retaining wall. We take the height of that permanent shoring wall and impose it down into our back retaining wall. This was suggested from the geotechnical engineer. And that load again is analyzed into our system. Moving on, we have building 1B. This is going to be a very similar structure to what we saw before, just slightly smaller. We again have the same buttress and wing wall system and back retaining wall system. We're utilizing the same methods as far as sliding is concerned. We have the passive pressure, the coefficient of friction, and we have tie downs at this location. again, there's the same TC couple as before. That's the design. We could take a look at the wing wall for this. It's slightly different. We do have one level of concrete, which will allow the wing walls to span vertically. And cantilever past that diaphragm as well to catch that little bit of soil that's above that. As far as sliding is concerned for the wing walls, so again, we're utilizing passive pressure. And then the section 3 shows the wing wall on the right-hand side of the building. This wing wall is not taking a lot of load because we have an adjacent structure next to that. That's building N1. So this red section that you see right here is the only soil that's pushed up against this wing wall. So we're seeing pretty light loads there. Moving on to N1 and N2. Again, it's going to be very similar to what we saw before. We have the typical buttress wall and wing wall system and the back wall. One thing to note there, this is just a buttress wall on this side. It's not a wing wall because there's the unit there, D9. So there's no soil pushed up against it. It's just used to transfer load from the back retaining wall to the buttress wall. Again, it's all the same methods as I've described before. We have our passive pressure, our friction, and our tie downs to resist sliding. And the same TC couple that I've mentioned before. And on the right-hand side, we do have our wing wall for unit N2. Again, we have a concrete diaphragm, which allows this wall to span vertically and cantilevers past that diaphragm to catch the soil here. And that is all I have for you. I did notice that, John, when you were talking about our drawings, there was a September date on there. We did have a December set that was set, so hopefully we can get that to you if you don't have it yet.
Am I the only one that didn't? Ben or Craig, did you guys have any updated?
No, I just got the ones that I got originally. I didn't see any emails with new drawings attached.
I went back through the emails. They were there. Everyone was on them, right? December 2nd, 3rd, 4th. All this discussion about the new drawings being completed, and Tom sent another link. We all were on there. It's kind of upsetting. Sent to Willie on December 5th, and everybody is on there and saying that they're available to the Dropbox link and announcing that the new drawings are ready the next day. I wish if people hadn't been able to access them, they would have notified us. That's disturbing.
So Mark, you're saying that they were available, made available to everybody?
Yeah,
Okay.
we're all in the emails. Yeah. December 5th, Tom sent one to Willie saying what files they were in, and they were available through the Dropbox link originally provided to you. There's an email with the Dropbox link from Willie on December 5th asking, and then there's some requests for updated calculations from shoring from Benjamin on the 5th, and then Willie asked me, and we provided a link. There's an email from Willie talking about how we're going to submit on the 2nd. I mean, lots of dialogue about it. I mean, you guys reviewed what you reviewed, but it's disappointing.
Okay. Well, we all need to have the most updated, so whatever it takes. Whatever link I just went on this week to check, I couldn't get on. So I don't know if there was a different link than the original one.
I think Tom said on the December 5th that it was that he was seeing them up on the original link, and if people weren't able to access that, it would have been great if someone could have let us know. I don't know. Um, but yeah.
All right, well, I think the best thing we can do is make that link available again and make sure we can get on it. And so we can all have the same thing to look at. As far as the rest of the meeting, if anyone needs to take a break, we can take a couple minute break. And then I'll address the geologic portion of the project, and then we'll throw it to Craig. And Craig, probably during yours, we can weave in the shoring, since it's probably more geotech than geology. You can weigh in on at least what you can with what you've reviewed. And then we'll go to structural.
And Eway, you know, if can you? Tom is the one who was putting things, and Tom's not here this week. Can you access that link and make sure all those latest documents were on there? And
Yeah, let me double check the link.
and I'll forward to you.
I just looked at the link, Mark, and I did see the documents there.
Oh, you see the documents there? Yeah, the last email I saw was the December 5th from Tom to everybody. I'm gonna put Eway on here.
The very bottom of that particular email that came from Tom on the 5th, there is a link, and I just opened it, and it has documents dated December.
Yeah, so is this here? I'm gonna copy it from the November. I'm just gonna hit send everybody again. Maybe if someone on the SAC could open that up and see if it works for you.
Yeah, that opens.
And are the drawings the December 2nd drawings?
Those are them. And Mark, I did find
the
the
third
email
file.
back in December, and I also was able to open that link. So, I don't know what, you know, from my standpoint, I mean, the geotech report hasn't changed. So, really, the primary review is looking through the shoring, updated shoring, which we could do fairly quickly.
There have some been updates to the geotechnical report, Craig.
So the December one has an update on it, because it's the one that I got, looked like it was the same date in July.
There's not been an actual update to the report. We did the updates through those two addenda letters.
Okay, yeah, I
supplemental
got,
recommendations.
I got those, okay, no, I'm good.
So really there's no change in the recommendations themselves that weren't covered by those addenda. Some of the finished floors did change. And so some of the concepts on the, particularly on the south side, how our recommendations were taken is slightly different, but we didn't feel like it needed an update.
Yeah, for whatever reason, I didn't get the second supplemental. So if you could forward that to me, or if it's in that latest link,
Yeah,
that's
maybe
fine.
you can check and see if you. The second supplemental geotech letter. I think we sent those to Willie separately.
Yeah. I think the biggest difference is the fact that excavations have gotten a little deeper than what the original report envisioned.
So make
One of
sure
the
that
suggestions is that
the supplemental letter goes into the Dropbox. Any like material for that will go into the Dropbox.
Wait, can you add those two letters into the Dropbox? I think we sent them. I think I sent them separate to Willie.
Seems like the Dropbox is managed by Kyle.
may I make a suggestion is to have the project teams to count the basic difference, what the update drawing and or calculation is between the two versions. That probably is going to help with moving forward in this meeting.
Erwin, you want to take a crack at it? I mean, it was basically the completion of the drawings, right? From 50% CDs, 100% CDs.
I'd love to walk the committee through how I see the shoring being installed with this 16-page document. And I'll leave it to John to see if that's okay with the procedurally.
Yeah. Let's let me get through mine with the geology, and then that'll fold into the geotech for Craig and the shoring. So why don't we do that first? So if no one needs to take a break, I'll go ahead and start. So in my review of the geologic aspect of the geotechnical and geologic report, essentially the scope of work was thorough and comprehensive, including document review. Something that Josh didn't weigh in on was the air photo analysis that they did, site mapping, their subsurface test pits, geophysics, their seismic evaluation, lab testing, analysis in their report. So the general scope was comprehensive and fairly thorough. And with the difficult site access, the main thing that I always look at and often have to request additional information is subsurface exploration. And most consultants shy away from doing enough of that. And so it's something that's very common for us to ask for. In this case, I think the test pit data combined with the geophysics. Is somebody running water in the background? Does anyone else hear that?
I think it's Harvey's audio.
Okay.
I don't think so. I don't hear anything here. But let
You're
me
highlighted every time we hear that.
A faucet
noise.
running.
let me mute myself. Does that help?
That seemed to have helped. Anyway, reviewing the data, the one thing, Josh, your site plan showed additional trenches in green that I haven't seen or wasn't privy to. So that's information that if you have any logs on that, please forward those as well. I just had the 5 that you did initially. And again, I agree with your findings. I don't have a major bone of contention with the subsurface interpretation. I've looked at aerial photographs, similar years that you did. I don't see any evidence of instability, even though they cut that slope in the what looks like the 30s for Diamond Street. There was no indication of instability, so I don't have a high level of concern that, especially when you guys shore and stabilize the cuts, I have no qualms with what you're proposing and the slope stability evaluation that you've done. The conclusions of Langen's report basically indicate that the typical geologic hazards that are evaluated from a seismic standpoint, slope stability standpoint, they indicate that they all have a low risk to the proposed development, and I agree. Their main constraints include soil creep and superficial raveling, which they mentioned, the hard rock excavation, temporary excavation, instability, surface and subsurface drainage control, and the general slope steepness. And I agree with those constraints and don't see any others that they have missed. The only thing I was curious, their evaluation of the landsliding to the north, and you guys have shed some light on that. I didn't have access to that report, but it makes sense. The variation in the geology and depth of surface materials down there was a significant reason for that failure. I did see on aerials that to the south at Walter Haas Park and Billy Goat Hill, what looked like an old quarried area, it looks like it had some instability there as well, but again, different geology, different facing aspect. The geophysics seems to match what you found in your subsurface, with the center part of the site being underlain by chert. Looks like there's a big mound in your geophysics in the center that corresponds with that chert, as being a little bit harder than the surrounding sandstone. I am curious as to the contacts between those units, and I know you didn't find those in your test pits. You'll have to be, and one of my recommendations will be that you're out there during the excavation and document the geology as they're uncovering it. The recommendations that Langen has provided appear reasonable, although I think they've changed, and there's probably an update that I haven't seen. In their report, they recommend piers for certain parts of the unit, but I think those have been dropped down so that the pier recommendations are no longer valid for any reason. I am curious about the micropile letter, and maybe that's been updated with the second supplemental, because I obviously didn't see any micropiles on the plans. And again, I'm looking at older plans. The one thing regard the constraint that they documented with hard rock conditions during the excavations, and we can talk about this during the shoring, is what's going to happen out there from a monitoring standpoint and from a vibration monitoring. I didn't see anything on the shoring plans that spelled that out, but if the rock is that hard, certainly vibration monitoring is going to be valuable. And that's pretty much all I've got, and I'll throw it into Craig's lap. The last thing, and again, I think it's the under drains that Scott had mentioned. I didn't see those on any of the plans, and maybe they're on the more updated plans. And so we'll definitely be looking for a drainage plan that shows all the specifics of the wall back drains and the under drains, and see that in plan and section view. With that, I'll pass it off to Craig.
Yeah, from my perspective, from the geotechnical perspective, with the buildings being completely in rock, there's the risk of things going wrong is low. And I thought that the report's thorough, has, the recommendations are all reasonable. I saw some minor inconsistencies in the recommendations, but generally on the conservative side. And for instance, some one place passive is 4,000 PSF uniform, and a couple others it's 2,000 PSF. But those are all very minor things. I think, geotechnically, one of the things that I bring up because it happens to us is that those subsurface drains that goes underneath the buildings, it kind of falls within no scope, and so just to catch, that somebody has to put them on a drawing and figure out. They often have to go to some sort of box and so forth. So it's a minor thing. So really, when I think of it, I think more about construction. How's this going to be built? It's not necessarily. I think the parameters are okay. The bedrock becomes very hard with depth. Over 8,000 feet per second from the geophysical survey. So that tells me it's very hard rock. And I guess Erwin will walk us through. I'm wondering how you drill a soldier pile in it, but I mean the soldier piles maybe aren't as deep. That don't go into that really hard rock as much. I'm wondering about the permanent versus temporary soil nails that we can get into also. That's more about shoring. So overall, geotechnically, I have very minor comments on the report. Really no issues with the approach, the values in there, and thankfully the bedding and the fractures are positive for this site, which is shows up because there hasn't been stability issues in there, so that beneficial for the project.
Hey Craig, sorry, one question I was going to throw it in your lap anyway, and I kind of forgot, was the strengths that were thrown out in order from the geotech for the shoring. I think soil nail design had a soil strength and a rock strength, and I wasn't sure where those came from, and maybe Scott could enlighten us on how those were derived. I think you had 0 and 30 for the soil and 42 and 500 for the rock.
Right. Yeah, treating rock like soil is always a gray area. I mean, for the retaining design, it looks like the values are conservative for rock. Obviously, they're like a soil. In the soil nails, they talk about 30 foot of embedment. Not sure. I don't know if that was for global stability or what that was, but there was a recommendation in there to have use this skin friction as long as it's 30 feet into bedrock. I kind of have to look at it and see, where the soil nails end up, because obviously with rock like this, you want to tie enough of the rock together to stand up quickly, and global stability to be okay. But I don't know, maybe Scott can say where rock values came from for soil nails.
Like you described, we essentially took the idea that all the rock at various depths may be highly fractured, but appears to be hard based on the velocities themselves. And those fractures are pretty tight, so treated it like a frictional material. We did give it an apparent cohesion, because even removing some of those blocks themselves, because of the orientation of the bedding, so that's where that apparent cohesion of 500 PSF comes in. So essentially from published literature based on assuming it could be weak rock at any depth or fractured rock at any depth.
Okay.
Yeah, it's not different than we've for decent, you know, this is pretty decent rock compared to, you know, a lot of the rock that we've dealt with in other areas. So I didn't have any problem with those values. So that was really it geotechnically. Like I said, to me, it's more, you know, how's this thing got built? I agree, vibrations. You know, if you get into hard rock and you got a whole ram going, you know, I don't think there'll be issues with structures, but you're definitely going to get complaints. And so, based on experience in San Francisco, you know, some sort of vibration monitoring is just more to make sure that, you know, people know that they're, you know, the vibrations are low and not damaging their structures. So
we'll say we specifically do talk about survey monitoring for performance of the shoring in the geotechnical report. I don't recall if those have been fully captured in Erwin's drawings yet. They certainly can be mirrored there or added, and we don't take exception to, or vibration monitoring will be required because of the construction methodologies that will need to be used, which probably will include coring and some HORAMs and things like that, which will be, you know, have potential for disturbance.
So that's all I got, John. I don't know if you want to, Benjamin wants to discuss what he has for shoring.
Okay. All right, Ben.
Ben, you're muted or something.
Ben, unmute.
Ben, are you there?
Talk.
Oh, there.
Ben, you're still muted.
He is not muted, but we could just can't hear.
Oh.
I don't know if he could hear us. Now he's self-muted.
He's not muted on your end, Willie?
No, he got his green microphone on, but no input.
Ben, can you hear us? Wave your hand if you can hear us.
Don't scratch your head. Wave your hand.
Mm-hmm.
How about
brother?
Maybe you can call in the audio or something.
Is the volume on your computer? Can you ramp that up?
Benjamin, we can see you. We
Can
can't
hear
hear
you. Yeah. Maybe you can log off and log on again, Ben.
While we have this interlude, does it make sense, Erwin, do you want to pull up the drainage drawings? Maybe show those and kind of talk through them. It seems like that's some interest in those.
You know, one of the things that Craig and John have made in comments on are the subsurface drainage. But we've gone through very extensive discussions on how to drain this, and there are plans for both the retaining walls and under slab drainage that you guys should review. And I believe Erwin has put those drawings together. I don't know why you guys don't have them.
Hello?
Ben, can you hear us?
Yeah, can you hear me?
Yeah.
Yeah. Okay, good.
Okay. I have a few questions on the shoring drawing, the general notes, the first page. And you mentioned some underpinning, I guess maybe that's some typo in there on the general notes. Number 10, you said mention some underpinning there, underpinning system. I don't think we have underpinning, right? Do you, Evan?
Hey, Ben. No, there's no underpinning.
Yeah, maybe you're gonna need to clean up the notes a little bit. And also, you're on the shotcrete, you mentioned 2,500, but the building code requires shotcrete is 4,000, right? And you might want to check on that. On the 1909.4, evaluate shotcrete, they require 4,000 PSI concrete.
Yeah, I wanted to evaluate at 2,500 PSI for moving on to the next lift. However, I can happily change it back to 4,000 because we don't get shotcrete less than 8,000 typically in the commercial market. I just wanted to call it at 25 and move on to the next lift.
But I guess that the building code says that unless the building department say that's okay. And also on the geopier installation procedure, you say settlement up to 1 inch may be observed, but based on the project with the city, they allow 3/8 of inches movement. And I don't know if this is acceptable for the city. And also on the tieback installation notes, I don't know if this is just apply for the soldier beam or they are apply both for the rod nail and the soldier beam as well. You didn't mention anything for the rod rail. On the tieback installation procedure there, and
yeah.
when you clarify that, see whether they include a rod nail as well, because of the testing or the other thing. And also on your drawing, you mentioned the oversized soldier beam for the permanent soldier beam. I don't know how you define the oversized soldier beam. You don't need like a coating for the protection kind of thing. And because you say oversized, I don't know what's the definition of oversized. Then so that you don't need the coating protection for the soldier beam, for the permanent one.
Sure. Well, my understanding was that in areas that don't have concrete, we have a certain degradation due to corrosion per year, and so that the cross-section member has been increased to account for that corrosion, so that these can be left in a rusted, uncoated scenario.
But then I don't know how you define your soldier beam. You decide for the calculation, so whatever soldier beam you specify works. But what you consider as oversized, you don't need coating protection for the permanent use. And I don't know what's the city requirement for all this, or how you define this. Whatever the size you come up with on your calculation, then okay, I increase to whatever size so that you consider the oversized so that you don't need protection. Not clear on that part.
Yeah, it's a good point, and maybe I should elaborate on it a little bit better. The biggest bending moment on those beams that they're checked for is where we have full encapsulation in concrete, and so corrosion doesn't become the driving design. So I think I need to give you a supplemental information there to show the rate of corrosion, and then the demand on the beam, which would be greatest right at the base of the excavation.
Okay.
So the biggest bending moment is we have corrosion protection already because we've encased in concrete in the toe. And then I guess where it steps on the dredge line or the dig line, I need to give you an updated calculation to show the demand there and what the availability is.
Well, I understand that calcification of the concrete, then you'll be get 3-inch cover, then you'll be fine. But that just exposed portion above the ground excavation, the retaining high portion, then I don't know how you can define that, say oversized or not oversized. Then you don't need coating or galvanize that kind of protection. But I guess you could take a look at it, or you give a more clarification or reference so that you say, okay, that's fine, something like that. And also, I saw your rock nail, then you just have one detail shown there, but on the plan or elevation, then you don't really number them and also call out the elevation and the type of load there. Then you draw some line in there, then by the time when people checking it, I don't know how they go, okay, this slice, check 1, 2, 3, 4, 5, whatever. Then I think probably should have some number and the elevation for your rock bolting or not nail. And so that when you do the testing or people look at it, how many or be drilled and how many being installed, then they can keep track of that. And so just nobody can tell which one is done, which one cannot done in the field.
Okay, that's a great point.
And also, then you didn't call out the elevation on all the rock bolting thing, and then when you draw the line, some look like a 10 feet on center, some is like a 5, 6 feet on center. But on the soil report, section 8.2, then they say what to cut not to exceed 5 feet. Then I don't know how that would match up with the recommendation by the geotechnical engineer for that.
Yeah.
I saw your calculation, so like a 4.6 feet per layer. Then you have a 8 row of tie back, but on the drawing you only have like a 5, 6 row, some is even less. Then I don't know how your calculation is kind of coordinate with your drawing.
Should I we talk through it one by one? And I think a lot of this has been evaluated in the updated plan set. But I'm happy to answer that. So, for instance, with the 6-foot cut question, as to work around that by having shotcrete staged so that we don't have any more than 6 feet of rock exposed at any one time.
And I guess if you call out your elevation on the rock bolting on the elevation, then everybody knows, okay, it's 5 feet or 6 feet, 10 feet, whatever, right? But now that you didn't call anything, then nobody knows exactly what's the spacing between the rock nail. But you don't have
again, happy to elaborate on that. Typically, when we record these, we record them at the elevation and the location. So, for instance, on this elevation here, which is one of the principal elevations, what we have is the drainage panel shown there.
Mm-hmm.
And then we have these would be installed per the notes at that elevation, which is less than 6 feet. What I wanted to do with these was try and give a little bit of flexibility. So we have a call out here that shows the maximum and minimum, of course, for this work here. So let me just look through these 16 pages and get it to you. So this was the updated set that calls out for those maximum and minimum.
You say this is
again
8 feet on center
I
max.
beg your pardon?
On the vertical dimension, if we go down to the second nail and the third nail, there is an 8 foot on center max, isn't it?
Right. So
Yeah,
for
that-
instance, to speak specifically to the question about excavation and exposures, I chose this 3 foot max for the top, so that typically these are installed 2 feet below.
Yeah.
So that would put us at a 5 foot exposure of dirt. And then once the nails go in, this shotcrete can get brought down more, and we can move on to the next elevation. So we can have intermediate shotcrete pours as necessary.
Well, you still 8 feet though, right? So you get 2 feet below the nail and then you shotcrete to the, whatever you excavate, the 2 foot below the nail, then your next layer, then you get another 8 feet max.
Correct, but you can have intermediate makeup pours as necessary.
But that didn't call on your nail installation, that kind of thing. That's I don't know. Maybe you should add that to it so that what the people doing it or inspector doing it, then knowing that's going to happen then.
Yep, absolutely.
Yeah, also on your calculation on that page, you show the input that shows like your elevation, or so only show like a 4.6 feet per each layer. But then I don't know how this would relate to your drawing. How you get that thing back to your drawing, saying this is 8 feet on center. How you design that compared to what you design and the calculation that doesn't match really on your drawing showing, because on your drawing your calculation page like 256 of 259, that page, it seems like you have 8 row of nail, so every layer is 4.6 feet difference in the spacing. But then now on your drawing, you say 8 feet max. And I don't know that loading everything, how you match your calculation.
I have the updated calculations here on this 259 page document. And this is the spacing there at 8 foot, 6 foot horizontal. And we can go through this now or later, but it's these
Well,
calculations match.
This elevation, this page, you saw like a 1, 2, 3, 4, 5 nail in here, right? But when the next
Correct, yeah, for a
go to
50 foot cut.
Yeah, then you go to the next page and see all your 256, you go your page 253, when your page 256, couple pages lower, then you write those number there. Your first row is a 4 feet and second is a 8.6, like a 4 foot 6. And the third, you add another 4, 6, and so on and so forth. Keep on, you have 8 row of the nail in here. Seems like to me. But then how you can say 8 foot maximum? I'm not quite understand how you get to that.
Understood. We've
Maybe you
addressed those.
modify your calculation or something to that match your drawing.
Yep, we can update that.
Also, on your cantilever soldier beam design, on your beam 121 to 139 there, and I found a little kind of weird because your beam 121 to 125, you say design height is 16 feet, 6 feet on center, you need an embedment 10 and a half feet. But for the 129 and 134, your retaining height is 20 feet, the same 6 feet on center, you require 9 foot embedment, which is less than 16 feet. And also for 135 to 139, you have a 27 feet retaining height cantilever beam at 6 feet on center. You only need 15.5 feet embedment. Doesn't seem really right on the geometry because you're 26 feet high, then you kind of like a half of the retaining height embedment for the soldier beam. Then I guess you might want to double check on your calculation because like a 16 feet and 20 feet, your embedment would be worse.
Not sure which location we're talking about here.
Well, that's on your page 17 of your calculation or your chart. Then your beam 121 through 129, you have a 16 feet retaining height. And then you need 10-foot-6 embedment. 121 to 125, yeah. And you
right here.
10-foot-6 and right there, yeah. But then the 129 to 134, you need 9-foot embedment, which is a 20-foot retaining height. How can that? Seems like that doesn't really make much sense.
Oh, thanks for the
and also
you have a
the one below, the 135 to 137, 139, you have a 27-foot retaining height, and you get 15.5 feet embedment. It doesn't really seem right on the geometry for the 27 feet high, that high, then the embedment so shallow. I guess you want to double check that because normally you want a 1-to-1 or something, at least 1-to-1 or 1.1 to 1.2 embedment for the soldier beam, for the cantilever.
yeah. We're gonna get back to you on that one.
Yeah, you want to double check on that. And also in your calculation of soldier beam, because you allow for 3 times the geopier diameter for the passive, then your geopier 2.2 feet diameter, then you use 3 times. But because you're only 6 feet on center, you probably cannot use 3 times on that. The passive.
No, it still reduces to only a 6-foot spacing anyway.
I guess that's one major part of my comment, and I think you probably need to double check your calculation and then some more work on the elevation so that you show all the rock bowl number and the layer what the roll elevation, and so that the people knows what need to do over there.
Great.
Okay.
I have a little comment here, Ben.
Yeah.
And also Sir Erwin. Regarding the oversized soldier piles that is exposed to weathering, isn't that recommendation should come from the corrosivities of the soil or rocks be checked for, and providing that recommendations from a geotechnical engineer?
Well, I guess that makes sense, but before we do all our project, and then if a permanent, then you need a coating, unless you get 3-inch concrete cover. But I don't know now, maybe the new code they change. You don't require that or something, I don't know. Because it didn't explain on the calculation on the drawing, say this oversized, you just call oversized, but then I don't know what's the definition for the oversized. You don't need the coating or galvanized protection for the soldier beam.
In terms of corrosion on other projects that have foundation piles that are made of steel, that we do retain a corrosion consultant usually retained on the project, and they can provide guidance on what kind of cover would be required given for a given design life. Usually it's something like 1/8 of an inch on any given side for a 50-year life.
Well, I guess geotechnical engineer or some expert can make some recommendation, then so that city will accept whether their recommendation is. Because based on my experience on the project I did, that they do require either galvanized or either epoxy coating, something like that.
Yeah, what I've seen is just a corrosion resistant paint on there, not necessarily epoxy coating.
Yeah, some kind of protection coating, right?
I think, Scott points out it's kind of this, whatever 1/8 of an inch, it's for below grade. This case, it's, above grade. So it's a little gray there because, obviously you can get more corrosion there. There's more oxygen going, in that situation. But my experience is that they're painted basically. It's even but anyway, we can move on from there. Just for the soil, it looks like a lot of the soil nails end up going off the property line. So there's agreement with all these neighboring properties to have soil nails beneath them. I don't know how many there are, but it looks like there's a lot.
Yeah, the neighboring property, they've reviewed and approved these plans.
Okay,
Yeah,
cool.
they sold us the land too, so they're
Including the city as well. It'll be under their roads.
right, and that's it's the private property owner is the one that signed off. The city, there's a minor encroachment permit that's been submitted.
Okay.
For their review.
Again, that would only be for temporary structures like the soil nails. Once the permanent wall's in, those soil nails are no longer useful to the design.
And I think that needs to specify on plan explicitly that is temporary soil nails that could be cut off at the end of the job or in the futures, and that's for those that is going into the roadway, and also for those that going into adjacent property that need to get spec out clearly on the plan, and additional permits for getting soil nail over property lines to have to obtain additional permits for the adjacent property as well.
Right. Could I jump in there on that as a procedural item? A lot of these plan sets, we've presented them all on one page, but they will need to be broken down into specific DBI plan check numbers for each specific address. So that's a bit of housekeeping. We understand that. We do want to keep these in one plan set right now to gather everything, and then as they get collated, they may get broken down into specific lots.
No, I think that's beyond what we're dealing with in the SAC review. But just for clarifying that, as a side note here, is that if the lots has been subdivided, then separate permits will be required. If the lot is one property, then you do not need to subdivide in separate permits. So that is the important piece of that.
Yeah, I thought for the shoring and excavation, and I don't know if that Tony is Tony Sanchez Correa, but my recollection was it was going to be one shoring and excavation permit for the whole site because it has not been divided up yet.
That's correct.
Well, that is one set of plans, but they might have.
Yes, but then Willie, you're correct. The neighbors, we have to separate out the tiebacks that go into the neighbors across the property line. We have to put a separate title block and an address for that neighbor's property and request a permit for that neighbor's property. DPW, we just get a MSE, a minor sidewalk encroachment, and we've applied for that and submitted our project documents as showing the tiebacks that go into the public right away.
And are there cross sections, Erwin, that you've generated that show the angle of the tiebacks that extend under the roadways so that we can or DPW can determine, you know, if there's going to be any conflicts with utilities and whatnot?
Yes, they are part of the DPW set. There is no conflict there. Everything is 5 feet away.
So Erwin, I looked. It looked like you have some tiebacks going into Diamond Heights Street, and it looks like you're crossing the sewer line in the center of the road. Have you looked at that in terms of a cross section, like mapping out that sewer and seeing if any of your tiebacks will be hitting that? Because from your image on SH20A, it looks like on Diamond Heights, your tiebacks are going across that sewer line.
Mm-hmm.
That's correct. They're going to cross it, but they're not conflicting with us.
So you've mapped it out and looked at it?
That's right. Yeah. Mm-hmm.
You might like to include that in the cross sections on your plan. So there's some things that you know you have looked at that one here because that is important item. On that lines of thoughts, I have a couple of questions. Number one here is regarding the angle of the soil nails going in different directions, how that is affected by the rock joints deep directions. If actually there is any correlations regarding its capacity and length versus the rock joint directions. As the currently the informations was you know, the investigations were only superficial pits, which does not go to the depth that it is the soil nail is going to go into. So that's the first question I have. And the second questions I have is regarding that Irvins was having some early on have some presentations regarding the soil pressures going into the retaining walls, and apparently when you have a stepping retaining wall, you start the lateral pressure from 0 at the levels which is not at the surface of that slope. So so I have questions regarding if actually those are appropriate lateral low values that to apply to the retaining wall that is cascading.
I
Who
will
would you
try
like?
to answer the first one. Let me start there. In terms of the rock jointing, you know, we haven't seen any indication at depth, especially where we're going to be having these elements, that we have any open joints or with gouge or anything within them. And so the diameter of whether it's a soil nail or a tieback will span across. You know, if it happens to align perfectly with a joint, it would align across multiple blocks above and below it. So we don't expect a reduction per se in the skin friction if it happens to align perfectly with the joints. We also, the likelihood is with the length of tiebacks and elements we have that it would be continuous along this entire length, I think is incredibly small. So it's not a specific worry we have.
As more layman's questions on that, does the deep angles of your rock joints is supposed to be higher or lower than the angles of your soil nail directions to be favorable?
I don't know that I understand the question. Can you say that one more time?
Well, I think he's getting at the Josh showed the test pit with the rock strata dipping what might be at the same angle as your rock bolts or soil nails. I think that was where Willie's going with that. It's a good question.
Yeah, so a couple things is one is we do see variable dips in the rock that we encountered. All of it was into the slope, so it's not that we have one set that's always exactly at one planar length. And then the follow up on the engineering aspects of pulling out a tieback that's in those blocks is we would be in multiple blocks just because of the diameter of any of those units. Sorry, any of those structures that we'd be putting in.
So I think the root of my question is that what would be considered a favorable dip angles for that retaining wall once when you are putting tiebacks in the rock nails to tie the blocks together.
Any orientation that wasn't perfectly parallel would be favorable. If it was dipping a little bit shallower or a little bit deeper, would not affect. As long as you can engage multiple blocks, you don't have a mechanism for unfavorable dip in that structure orientation. And Josh, I don't know if you want to weigh in the geology side.
Well, I think the proof is in the pudding when you test them. If I assume you're going to be testing some before you drill all of them, and so
absolutely
you would find out early on if you had to change your angle a little bit.
So
that's exactly
is
right.
there a testing program in place currently?
Yeah, I don't know if it's been documented in the plans themselves. We've suggested they be tested in accordance with I forget which mechanism it is, standard procedure for putting in soil nails as detailed in our report.
Yeah, I think Erwin has it.
You got
yeah,
it
it's
there.
outlined on the plan.
Perfect.
There's not a lot of information regarding the rock nail testing on the soil drawing though, because only the one detail shows that. I think that's details. Let's see what.
Erwin, I had a question for you. I do see your drainage. You have the sub drains included on your drainage plans for the walls there. So what is between the slab and the rock? It looks like you have hydroduct on there. Basically
That's right. Yeah.
Yeah. Is that, Scott and Richard, is that okay? I mean, is that a vapor retarder? Is that what goes?
No, hydroduct is a prefabricated drainage panel, conventional
Right.
panel in lieu of rock, considering the volume of water we expect. So we've allowed to use continuous panels underneath the slab instead of a rock section.
There's just basically a are they sloping down toward the trench, the subgrade?
No, it's
It's
carried
flat
underneath
against
the slab.
Just flat, yeah.
I got you. And then what goes on top of the hydroduct then, between the slab and the hydroduct?
Would just be waterproofing.
Waterproofing, okay.
Yeah.
The whole idea is to avoid excavating 6 inches.
Yeah, understand. Yeah, I mean, you'd like to have a little bit of grading. I mean, obviously the water is gonna, if it comes up and pushes against the slab, it'll eventually get over to that trench, so, but,
Yeah.
okay.
Yeah, we just have a panel and waterproofing versus a gravel drainage blanket.
I think all these need sand traps, right? Isn't that right, Willie? All those subdrains?
Yeah, those need to go through sand trap before going into the city sewer.
Yeah.
They probably need to have clean outs in place for the drainage. You have clean outs.
One of the questions we have, Willie, is do we need sand traps for every unit, or can we
Get all together and then put it in a
get
sand
them all
trap before.
together and use, a limited number?
The sand trap has, before you go into city sewer, you need to go for sand trap.
No, but do we need one for every unit, or can we have, one for a combined number of units? I've run into
Yeah,
this
that's
problem.
exactly what I said, is that if your drainage is going through only one outlet into the city sewer, that's where this connection is. If you connect directly to city sewers, whatever the direct connections need to get a sand trap.
Yeah, it looks like,
between you
looks
can
like
do
you're kind of
clean
spaced
outs.
far apart, except for maybe one at the end there where they can connect up on the north side. But the other ones are kind of spaced far apart to connect them before you go to the storm drain.
Hi, this is Christine Gursky with BKF Engineers. We have another utility plan too, and we've coordinated these kind of drainage lines, and we have inlets at those kind of solid combined pipes that incorporate sand traps. So anywhere there's a lateral to the street, we would provide a sand trap via a drain inlet, just city standard detail style.
And the subdrain ought to have, in key locations, reasonable length to have cleanouts. But this retaining wall is pretty tall. So I think that the second questions I had was regarding if the lateral pressure diagrams as is shown in Irvin's drawing that was in his demonstrations for the cross sections with those cascading walls is adequately address the real pressure on them. Because there were some color exhibits that was brought into during his presentation.
So that's on the structural drawings there.
Yeah.
And what we're talking about is having a retained cantilever wall that's set back from the wall.
Yeah, cascading, actually, not this one here, but those that has a step.
There you go.
Cascading wall, the one on the left-hand side, there was one showing the one on the left-hand side. There was a demonstration that shows two triangular blocks, one for the top, one for the bottom. This one does not even
Previous
show
page.
that. Yeah.
Going back one?
Yeah, I think it's probably further back, possibly. Yeah, there we go.
I think it's the one with the
You
garage.
just missed it. You just missed that.
Go forward one.
Yeah.
There we go.
Right there.
Yeah, so here what we have is that we've got the one wall system that's taken up by the structure, and the lateral load is dissipated within the footprint of the garage structure there. And then the vertical loads on the other side of, all the columns coming down on the other side of the garage are carried right into that wall. So we don't have surcharge pressures from the foundation itself that are pushing down. And so we do get to start over with a new pressures there that take that into account.
I think, Willie, are you talking about the soldier piles that are, is this a cantilever soldier pile wall behind here, the one in the upper part?
Actually, it's the lower part. The lower parts, that is a certain load that's going through the garage slab that is going to go into the lower wall.
So all the loads on that are close by that wall are carried into the wall itself. So the structural loads come down into the combined wall that becomes the lower retaining wall.
Now, the green wall, the green slab right there, yeah, that's the part there. That's lateral loads coming in from the lateral walls on the left, pushing into that slab, into the lower wall, wouldn't it be?
Well, yeah, I think what we did is we checked the sliding, so the upper box to the upper left, the sliding resistance at the bottom of the green slab takes out the lateral resistance before that load makes it over to
Gets
the
to
wall.
the other side.
And that friction is being resisted by the soil below, right?
The rock
And the
below.
soil below has to exert that load into something.
So I mean the
we can
because this is we can provide a response to that question, but because it's rock and we're able to take it out before it gets to the other side, doesn't seem to be a mechanism to really apply a lateral load on that secondary, the lower rock wall system.
Yeah, we have to be careful here. One's friction, one's a surcharge. And the friction load can be taken out in the rock is sliding resistance versus a surcharge that's going to be imposed on the wall below. So, I mean, I don't want to confuse the two, but as Scott said, we can respond to that. But there's a friction which is purely in at the rock slab interface, and there's surcharge that's actually a vertical load that gets translated into a horizontal load imposed on the wall, and they're really two different things.
Well, that's the heart of the question here, is that the load got to go somewhere. If you think that the rock is able to sustain itself, then you don't even really have the second triangle on the bottom, right? Because you have a piece of solid rock standing, it can stand straight up as a cliff.
But I just want to be clear that the frictional load is not necessarily a load on the lower retaining wall.
When it's soil and when it's rock, it would be different. The rock can stand on cliff. If it is of that, integrity, so to speak. So I think we have fractured the rock there, so which is a different story, isn't it?
Yeah.
Certainly can provide a response there. I mean, point taken. If this was soil, we would be taking a look at where that load was shed and whether or not it would translate over, how it would dissipate. And so, I don't want to take the conservative approach that we've done with designing all these for essentially as a intact soil and do double penalty. I mean, yes, we wouldn't need that. We don't have a lower triangle if it's one big block of rock, but that's not actually what we're saying either. So we can provide a response to that.
Great, thank you. And early on, I think Ben had some questions regarding Irvin's calling out 2,500 PSI Short Creek, and if it is going to be supporting any building with 3-story or above, then it needs to at least 3,000 PSI for any of those concrete material. That's per code requirement.
Okay, thanks for that clarification.
Okay, we haven't gone to not. I just want to remind the chair that we haven't gone to Harvey for architectural.
Right.
Was that an invitation to go to Harvey?
Yes.
Good. Okay, we have discussed at some length the disposition of groundwater and how it gets out to the street through the laterals, but no one has discussed how roof water is dealt with. Could you cover that?
Leeway, is that you? Would you be on the roof water as the architect?
Christine, do you want to take that question?
Yeah, I can help out with that question. So, a portion of our roof area is collected and sent to a cistern for reuse on site. And then the remaining area that's on the upper side of the site, the cistern will reside in the building that has the garage puzzler. The lower sites, since those roofs are lower, will be going out to the combined sewer system. Our piping on site will grab the downspouts coming from those buildings or the storm drain connections, and then sending it to the combined sewer system in the street. The cistern is going to be used for irrigation on site, and there is an overflow pipe that is connected up to the Diamond Heights Boulevard Street combined sewer system.
Thank you.
You got any further questionings or comments, Avi?
No, I do not.
Okay. Let me ask the questions here. I see there is a flight of stairs that's kind of wiggling around, downhill in the middle of the site. And apparently it is been, having the architectural laid out. Maybe that's not really structural laid out. That was early on in the presentation. That uses some levels of, as I see on the plans, some elevated structures on piers. And I'm just wondering if those actually needs to get specified as surcharging any part of the retaining structure.
I would direct that to IMEG.
I'm trying to think
specifically.
I'm trying to think of where we have elevated. I know we have elevated structures on piers below at the bottom side of the retaining structure. Well, are you talking about something up at the top?
It's in the middle of it. There's a flight of stairs that's wiggling around. I think it's crossing the site.
We have two stairwells, one that kind of wraps around, one's more of a straight shot, and then one kind of winds its way down.
Yeah.
One's on the north end of the site and one's on the south end. Which one are you talking about?
This is the ones that is between building 1A and 1B.
Yeah, that's the north end. Yeah, between duplex 456 and then 789. Does that help, Joe?
Yeah, so that stair that's a kind of a zigzag stair. So I think we meant there's a retaining wall, a permanent wall structure that ties in between duplex duplex 6 and duplex 7, and then that's a sheer cut right there, right? And then the stairs are then supported off of piers, but they're at the bottom of that cut, so they don't surcharge because they're at the bottom. If we have an architectural section of those stairs, it might help show what's going on. But that wall is a full cut from the full that retains that full face right there. So the supporting structure is at the bottom of that wall.
Okay. I noticed that is a stairs that's kind of wrapped around the top side on the high side of the building. I think it's 1B, right? There's a flight of stairs that's right around the top of the retaining structure.
At the top of 1B there, that's just a walkway for the set where it's D7B, 8B, 9B. Yeah, so right above there, that's just a walkway. So it's not actually a stairway. That you can get off the stairway and go there.
Now, that stairway is on the low side of the cut, right? It's not on top of the cut.
Yeah, the stairway as it comes up from the south, then it zigzags, and that's an elevated. It's an elevated structure that's built up with a pier, and it's supported. The foundation of that is supported at the bottom of the cut, and then as it's an elevated section. As it goes up, it crosses a line. Trying to figure out how I can draw here, but it crosses a line. Yeah, right there. If you draw, yeah, exactly. So as it crosses there, then it turns into a slab on grade. Essentially, it's just on the surface profile above that retaining wall. But everything to the south of that pink line is founded at the base of the cut.
Okay, is there a cascading retaining wall here for landscapings below the stair?
Oh, it's a continuous cut.
They see a couple of lines in here, right? Below the red, you have a couple more walls in there.
Yeah, I think that there are some.
It's a little confusing there, but currently there's no landscape in there.
Yeah. Typically, we would use the piers to avoid surcharging a retaining wall. If there's a condition that you question, point it out to us and we'll take a look at it. But typically, adjacent to retaining walls, we use piers to take the loads down below the zone of influence so that we don't have a surcharge. If there's something that you're concerned with, just point it out to us and we'll take a look at it.
Yeah, I'm just seeing these figures that is a couple, looks like there's some cascading retaining walls here.
Yeah. Well, again, the piers are usually employed to get below the zone of influence of the retaining wall so that we don't increase the loads on the retaining wall. But if there's something that is of concern, please just point it out. We'll take a look at it.
Yeah.
And Iway, you know best. Are those retaining walls? Those two things?
These are, I think it's only for the landscape purpose. And Erwin, if we can share like the drawing you have again. Let me go there. So I think it's only the lower part that has some landscape elements, but it's not retaining a log hole soil behind it.
So those landscaping retaining walls that come after the initial tieback walls, right? Or actually those are soldier pile walls.
Those are soldier pile wall, right? The permanent soldier beam. And the river beam over there.
Yeah, Philip is going to take a look at those during plan check then, as those are post-installed retaining walls.
Yeah, no problem. I'll flag it.
Okay. Chair wallets. We have agendas, and I think we have one part is going back to the agenda. Let's see.
Can I just ask? I'm a total layperson here. Like, did everyone? I don't know if it's Erwin or Iway or who needed to follow all those things that are asked for. It sounded like Ben and Erwin had a thing going on where Ben was suggesting things and Erwin was getting amended. Are we clear on what the next steps are for the design team in terms of responding to things and clarifying things?
Yeah, at the end of the discussion, I always wrap up the action items and make sure that all parties are clear on what's being asked for. And in this case, we always try and end the meeting with a discussion on whether or not we need another full SAC review to go back over the items, the action items. And we should have a discussion amongst the SAC members about that, and Willie and Philip, especially with the plans that we all didn't review the same revision dates. What I'm seeing is not a lot of fatal flaws as far as large technical issues that could throw a big wrench into things. And correct me if I'm wrong, Ben or Craig. So where to steer this, I think we should be clear on that, and then we can go through the action items and make sure everyone's clear on those. Is this something where we can, now that we have the latest revisions, the SAC members can review those, and the project team can submit the remainder of the action items? And can those be reviewed by the individual SAC members and respond to DBI with a letter, or do we need to discuss in another SAC meeting these action items? Because it sounds like a lot of them, there are some, Ben and Erwin have, a list, and I'm writing these down too, and I want to go over them and make sure we cross-reference with the project team. But maybe I could get some feedback from Craig and Ben and Willie and Philip on the need for another SAC meeting.
Yeah, this is Craig. I don't think we need another SAC meeting. I mean, typically for these reviews, the comments from each reviewer are, provided and get responded to. I mean, we could have a meeting internally after we get a chance to dig through these. I looked through the Erwin's drawings, the shoring drawings, and the sequence drawings are very helpful in how it's going to be constructed. So I think that I think that's pretty clear that we won't have to dig into those a lot more. But it seems like the biggest comments are from sort of the details of the calculations of the shoring, which it seems like those need to be addressed. I don't know if Ben needs to prepare a memo with all those or how that is. I mean, normally you want them in writing rather than trying to get it in a meeting.
I can prepare like a summary, whatever, submit to the city or DBI or Billy or Philip, and then so that they can distribute to the design team. Does that work that way, or?
I have minor ones I could provide. Get everything, review these, and get it to the SAC. To DBI by within a week, and I don't know what Ben's time is, but it seems like
do that, because I already wrote down something, but then I can submit a summary, whatever the item is, to the DBI, and so that they think how they want to distribute to the design team to follow up. I can do that, in a week or so.
This is Willie, and I just want to remind the SAC members. I think the important thing here is that the items that is on our agenda basically have been satisfied. Then the others, small details regarding the project documents. That ones Philip can actually follow up on and have those things buttoned up. And actually, with the latest design drawings, if we provide that particulars, I think all the information has been discussed on this, and provided the applicants actually have a revision that basically satisfies the comments to resolve the comments, I think we might be good. But this important piece here is actually, well, let's go through the items to see if what you see so far with the design are in general in compliance with the particular items that has been listed here. So just a reminder on that one here, say if the safety integrity of proposed design constructions is good, and in fact that's the grading construction activities that have been proposed that would have any safety and slope stability issues during the construction sequence provided, and also after the construction, and if there's an interim measures that is going to mitigate any potential sliding erosion of the site, if that has been addressed, and also the important thing is the validity and appropriateness of the geotechnical, and structural design concept and criteria that has been put forward is adequate. And adequacies of these investigations, geotechnical and geological investigation, and the study of to reach the recommended design parameters, are those adequate? And also the evaluations of the grading design in this particular, in the planning future structures and developments, and if that is going to be any determine the appropriateness of the capacity to perform satisfactorily without failure, and any perpetual limitations on the site to impose regarding the level of future development, such as future excavations and vertical horizontal additions from the original plan. Now, this part here we have not discussed, but that's some things that the SAC should address their findings on. Constructabilities of the proposed structural detail and construction sequence and methods, and looks like that has been discussed and presented. And also the sufficiency of proposed inspection, testing, monitoring to be provided prior to, during, and after construction. There are some monitorings of the vibrations discussed, and other than that, I do not see any other discussions on this regarding the testing. We did talk about some testing on the soil nail, but that documents has to be provided. Now, items to be reviewed include not limited to geotechnical, geological investigation, study, design, detailed drainage, erosion during and after construction, construction erection methods, appropriateness, adequacies of proposed shoring design, quality control, and special inspection specified. Now, those things that I did not hear any comments on. However, that is part of the consideration. If any part of those you consider missing in the revised drawings, then we may determine, if that is been done or it has not been done, and you might have considerations of hinging some of that if that is not satisfactorily provided in the after looking at the revised drawing. We might have additional discussions on, but that determination has to come afterwards. In essence, we can always have the capacity to ask the design team to come back for another meeting if those happens to be, not in line with what has been promised in a sense. And site monitoring plan during and after improvements, installations are constructed. So those I think is still going to be a monitoring plan that need to get details. But if there's no big concern and it's run-of-the-mill type of monitoring plan, I think we can go without a second meeting. So I mean, that's what I see, but not necessarily in the view of the SAC member. Okay, and also the last one is necessary follow-up of the SAC for additional site finding by geotechnics, geologists regarding any additional investigation that needs to provide the assumed geotechnical, geological design parameter. That's a big piece of that, hinging on if actually that could be done without a second meeting, or that actually is necessary, or by and large, On the other hand, is by and large, that's all the big concerns being satisfied. Okay, so I think, in conclusion of this thing here, that's what want to interject on this agenda to have that. And then after the public meeting comments, the SAC can do a final panel discussion on what to do and if all those items are satisfied. Thank you.
So, Willie, this is Richard. We are committed to perform the monitoring and inspections that are required by code. That's a given, and I think Emerald Fund understands that, including the geological, the geotechnical, and so on, inspections and monitoring that's required for shoring and foundation. If there's anything in addition to that that the SAC committee is going to require, I think it behooves you to point that out to our client, Emerald Fund, Mark Babson, and others, what that might be. But according to the monitoring and the requirements by code, we are committed, and I'm sure Emerald Fund will engage us to do that. But if there's anything in addition to that, that either, well, let's just say the SAC committee requires, let's have that up front, please. We are not trying to cut corners here. We're not trying to do anything to circumvent the code. But right now, that's what we're committed to, is the inspections that are required by code. So please let us know if there's anything in addition to that, and that you as the SAC committee will require.
I think we've already mentioned, the vibration monitoring, and that's not a code requirement that I'm aware of, but it certainly behooves you and is in your best interest to do that, to save a lot of heartache down the road.
Okay, well, if there's anything in addition to that, please let our team know so that we can prepare for that and respond accordingly.
Sure.
John?
Yeah, Harvey?
I just want to support what Willie said and take it a step further. The one item on the agenda that was not discussed at all relating to the potential future development of the site seems inherently moot because this project pretty much fills up the site and definitively develops it. It seems to me, based on my experience with past SAC reviews, that the goal of a SAC review is to identify questions of concern because of the unique and difficult characteristics of a site, but not to delve into the level of detail that is properly a part of DBI plan review. And it's certainly my opinion that nothing of that kind of deep concern has come up in this discussion today, and I would seriously question the need for another meeting.
Yeah, again, as I mentioned earlier, I agree with you.
So based on what Harvey's saying, do we need to, I mean, essentially what, some of the stuff that Ben was doing, it's basically design, issues that I don't know that, if is that DBI's responsibility to go through those calculations, or is that something the SAC should be commenting on? I mean, it's not the big picture stuff, it's details.
Sorry, Mr. Irwin. I do want to make sure that Ben and I are on the same page, and any comments that Ben issues to the shoring will be addressed because he is the expert, and there is typically, very sensible comments and some housekeeping, so it's good to get those. So I would like to see those done anyway,
Yeah, the only concern I have is regarding the embedment for those soldier piles to see their assumptions and appropriate.
I took a look at that, and I'll be bringing this up with Ben, but the way I presented it was actually needs some clarification because there's some severe adverse slope. Actually, those figures we're talking about an initial staged construction. So those figures where the cut numbers are larger than the embedment is down at the bottom of the slope where there's where the top of the existing will be cut off. So there's a housekeeping thing that needs to be fixed there to show that the actual finished condition and the finished embedment jive a bit more clearly. So that's on me to tidy up. But thank you, Ben, for showing that. So yeah, there won't be there's no fundamental issue. Essentially, a cantilever has to be more or less the same embedment as the slope it's holding.
Yeah, those couple of them, they are much less than the retaining height. That's why kind of doesn't seem right on the geometry just by looking at it.
Yeah.
But then also you will double check the calculation, the 3 times the diameter, because you're 6 feet on center, you probably not can use three times the diameter for the calculation as well. Maybe you can look into that.
Yep.
I think there's some shared responsibility between the geotechnical engineer who will be reviewing the assumptions of the shoring and design calculation. So I think in the past, I think a lot of geotechnical engineers give the shoring engineer a free pass of approval without really going through particular details. And I find a lot of holes of shoring calculations that is not according to the geotechnical report's recommendation and got a free pass. So hopefully this is not the case here because we are doing a heightened design review and it needs to be, everything needs to jive well. Thank you.
Agree with you there. We'll be reviewing the aspects of the shoring design that pertain to the geotechnical aspects for sure.
So Willie, does it make sense? I think maybe Craig threw it out earlier or Ben, for each of us to summarize more of our action items in a letter, distribute those to the team. They update their plans as needed for a resubmittal, and then we issue a recommendation to DBI based upon our review of that revised set.
Yeah, great.
Yeah, well, I think let's finish with the public comments piece here for formality. So we are entertaining, it is your floor, but may I suggest that it is take the public comments, then you can formulate some level of, panel discussions for motions, for further actions down the road to finish up this review session.
Sure.
Okay, so I think we're going to call for public comments. If there is any public comments, you can, when you call in the phone, you can put asterisk number 3 to raise a hand here. And I'm going to give it half a minute to see if there's any interested parties want to make comments.
This is the least interested the public's ever been in this project. Congratulations, everybody. There's been a lot of
At this point,
and this
we
is
did
the
not
least
receive any.
interested they've been.
We did not get any public comments, and so I think that the reminder, I already had the reminders there. If the major items that is, that is concerning the safety of and the technical completeness of the job and the adequacy of recommendations of this project, then you can formulate some action item. The second, formulate some action items that without second meeting is according to you folks' recommendations.
So Craig or Ben, do you have any other suggestions other than the one that I've thrown out? Or Harvey?
I think we'll submit whatever the question we have and to, I don't know, submit to DBI something so that you can formulate the action item and send it to the project team to follow through. And then we get not revised drawing, update drawing, and those that will look at it. If we have a need at that time, seems then we can decide, do we need a second meeting? But doesn't seem like we need one. If we can, the design team can submit a drawing to take care of the action item, I think.
Yeah, I agree. I think that's the way I would recommend going to. I think we should probably compile all of them and have DBI send them out formally to the design team or to the project sponsor, and then they distribute however.
So I think in this particular SAC, in order to do that, I mean, I suggest some kind of motions like the formations of the heightened review by this SAC have basically been satisfied with the review items that is on the agenda according to section 106A.4.1.4, with the exceptions of some detailed calculations and plan items that's the Department of Building Inspection will follow through under a list of items that to be provided by the SAC to follow through. If and appoint the submissions of the revision plan for DBI and the SAC committee for a final check. They would determine if additional SAC review meetings needs to be held for these permit applications.
Harvey?
Muted there,
Harvey, you mute. You're mute, Harvey.
There we go. Based on somewhat on what Willie just said, I would like to move that the notes of this meeting be issued to the project team, those notes containing a description of all action items that have been mentioned. The project team will then respond to those notes as required, including with updated drawings and calculations. Those responses will be distributed to the members of the SAC who will then, if everything is satisfactory, issue a recommendation to the DBI that final plan check proceed in accordance with the relevant sections of the code.
Do we have a second for that?
I'll second that.
Yeah, I think we should proceed with that motion, and I'm in agreement, Harvey.
What if
You want
you
to take a
ask for
vote?
a vote of the SAC members?
All in favor of Harvey's motion, say aye. Aye.
Aye.
So that
It
motion
passes
is,
unanimously. Okay.
so John Wallace approves.
Okay, so I think we finished with item number 8. So the last items on the agenda is adjournment.
Can I just ask a clarifying? This is all great. Thank you all for this expeditious solving this.
Okay.
Really, at the beginning, you asked for the architect to take notes, but it sounds like what's going to come out of this actually are individual notes from individual members. And so to try to save Eway time to try to assemble that, is that okay if that becomes the notes? The individual members sending their items to you and then you send it to us?
Yeah. No, I think you should combine them all together, but I'm going to send you, once the recording is available, I'm going to send it to you so you can distribute to your team.
Great. So we'll have the recording and then we'll have the collected to do.
Yeah, you collect it and merge them together because you might have some deviations on the understanding because each party's got, your party's got different understandings of, the discussions.
But and it's a good point, Mark. Yeah, so you guys generate the meeting minutes like we had discussed, but each individual SAC member is going to submit to DBI a letter with our individual action items.
John, excuse me. I don't think that's the way it should go. I think
that's what I thought you said.
No, I think any individual member of the SAC who has action items that they wish to detail should convey them to the architect, but the architect definitely needs to produce a single document that lists all of the action items in one place. That document should then be distributed to the SAC members so everyone can check off and say, yep, that's what we agreed on. And then the team produces the responses.
Yeah, I agree with Harvey on that. Okay, because this is a public meeting and everything's got to be open. And that, in that case, it will be all open.
So just to be clear, to the 4 SAC members.
The meeting minutes is to be posted up in our website.
Yeah, so from my understanding is that I will get a list of the items that you guys want to include for us to respond into the meeting minutes and then distribute back to you guys.
I think you should come through DBI. I think the SAC members give the list of items for DBI's plan review purpose as well, and we'll provide that information as an assistance to prepare the meeting minutes as we discuss in details on on all those items already. So it is a repeat of what has been discussed.
So all 4 SAC members will send Willie a email with their items. Willie will send me an email. I will send that to Yue, who will combine that with his take on the meeting minutes, and then I'll send that back to Willie, who will then distribute it to the SAC members. That sound right?
Yeah, that's right. So the thing here is that the process here is to be open. So what we are dealing with is just a summary of what has been discussed that has not been satisfied. That means that what I see here is that the general ideas of section 106.4.1.4 has been satisfied, with the caveats that there is details here and there that need to get corrected on the permit plan, and in essence, those got to be responded back to satisfactory to the department, as well as for the SAC members to make a recommendation for approval. So the idea here in general, the intents of the SAC review under the public forums under section 106.4.1.4 has been satisfied. That's the important piece that we're looking at.
It sounds like you're gonna create a project comment log, right? A SAC project log, a comment log, and then there'll be a response to each one of those comments.
To that nature, yes.
Yeah.
Okay, so I think that the process is clear at this point. As usual, there's only a few projects obtained one SAC review meeting. So that's a good piece of that. The preparations of all the cooperations of all the members of the SAC as well as the design team.
Thank you.
Okay, so I think Chair Wallace, then you have to solicit for a motion for adjournment.
I motion for an adjournment of the meeting.
Second.
I'm going to take a vote. Chair Wallace.
What was that, Willie?
Oh, you need to take a vote.
Call you back
Oh.
in a minute, Mike.
What?
I solicit a vote for adjournment of the meeting.
Aye.
John
Aye.
votes
Aye. Okay. Voted unanimously. Thank you very much. Meeting adjourned.
Thanks, everybody.
Thank you.
Thanks.
Everyone.
Thank you all.
Thank you. Thank you all.
Philip, you can stop the